Assalamualaikum and hi, my name is Muhammad Adam bin AZZIZI with the registration number 01DT21F1002. I'm from DT2A class.
Hai and Assalamualaikum warahmatullahi wabarakatuh. My name is NOOR IRDINA AUNI binti Muhammad RIDZAL. My number matrix is 01DDT21F1004. I'm from class DDT2A.
Assalamualaikum warahmatullahi wabarakatuh and hi, my name is Noor Azizah binti Hamid. My registration number is 01DDT21F1008. I am from DDT2A.
Hi, my name is AINAA binti ABDUL RAHIM. My matrix number is 01DDT21F1033 and I'm from class DDT2A.
Today, our group will be presenting about our discrete mathematics assessment, which is case study 1. For this case study, the topic is about minimal spanning tree, also known as MST. Before we proceed, let me introduce our agenda. Firstly, we will talk about introduction of minimal spanning tree. Next, we will explain the technique that we applied for this question. Thirdly, we will elaborate the solution and calculation. And lastly, the conclusion, which is the importance of the minimal spanning tree. Alright, now let me explain the definition of the minimal spanning tree. A minimal spanning tree, MST, is a subset of the edges of a connected, edge-weighted undirected graph that connects all the vertices together without any cycles and with the minimum possible total edge weight. That is, it is a spanning tree whose sum of edge weight is as small as possible. The key point here is a minimal spanning tree MST has the smallest possible sum of edge of its edges without any cycles.
Next, we move to technique and how to apply. To solve this map, we use Prim's algorithm techniques. What is Prim's algorithm? Prim's algorithm is a greedy algorithm that finds the shortest path through a weighted, undirected graph. This means that it identifies a subset of the edges that form a tree that includes every vertex and where the total weight of all the edges in the tree is minimized. Let me show you how to use Prim's algorithm with these steps. You can simply follow all these steps. Okay, here we go. Step 1. You must select any vertex and choose the edge and the smallest weight. Step 2. Proceed to include connected minimum edges into our MST at each stage as long as it does not form a cycle. Step 3. Continue until all the vertices are included. Let's start with an example. Following the previous step, we must select any vertex and the edge with the smallest weight. So, let's begin with A. Then, consider what is connected edges. So, we have 4, 2, and 5 connected edges. So, which of these edges am I going to pick? I'm going to choose the shortest of these edges. So, we'll go with 2. Okay. I've added B to my graph now. So, what are the connected edges that are connected to B? There are 1, 3, 7, 4, and 8 of them. Obviously, we must choose the one with the shortest distance. So, we link it to the B. So, now I've added D, and we'll see what connected edges we can get from that. As before, we will select the edge that has not yet been selected and has the shortest distance. So, it is 2. Now, I want to select the edge that has not yet been included and has the shortest distance, which I see is 3 here. But the question is, can I incorporate this edge? No, it does not. Why? Because we don't want any cycles in MST. So, if we add the edge of 3, we get a cycle between B, D, and E. As a result, we cannot add 3. Apart from these 3, we can see that 4 is the smallest edge. So, I will include 4. Let's see what edges we can connect to G now. Obviously, the shortest distance is 1. So, we can see which edges have yet to be included and what the minimum distance is. We have 4 and 5. Can we include these edges? No way, because it will create a cycle. We are now at number 6. Can we include number 6? Without a doubt, because it does not form a cycle. Following that, we included all of the vertices in our subgraph. So, this is how the Prim's algorithm will work to find the minimum spanning tree of a graph. We can calculate the weight of this spanning tree as 6 plus 4 plus 2 plus 1 and plus 1 equal to 16. That's all from me. Thank you. I will pass it to my friend to continue the next part.
Next, I will explain about this map. Our map for case study 1 is map 5. This is the diagram tree we got from the map. For this map, we have applied Prim algorithm techniques to solve it. Firstly, we count how many vertices there are on the map. On this map, we have 32 vertices. Then, from the total of vertices, we must enter the number of vertices into the formula, which is n subtract by 1, where n represents the number of vertices on the map. After that, the answer we got from the formula should be the number of edges in the tree diagram. The calculation is on the screen. First, we pick the smallest weight, which is from vertex 1 to Langkawi International Airport Kedah. Next, Langkawi International Airport Kedah to Restoran Selera Kampung. Restoran Selera Kampung to Kampung Darat. Kampung Darat to Kampung Cenek Kura. Kampung Cenek Kura to Cili Kampung. Kampung Cenek Kura to Kampung Bukit Lembu. Kampung Bukit Lembu to Kampung Perana. Kampung Perana to Kampung Bukit Temin. Kampung Bukit Temin to Restoran Kak Yan Nasi Campur. Restoran Kak Yan Nasi Campur to Kampung Padang Gading. Kampung Padang Gading to Kampung Baru Teluk. Kampung Baru Teluk to Recreation Park Lubuk Semilang. Recreation Park Lubuk Semilang to Langkawi. Restoran Kak Yan Nasi Campur to Taman Desa Kemboja. Kampung Bukit Lembu to Kampung Bayas. Kampung Bayas to The Fat Frog. The Fat Frog to Restoran Nelayan Langkawi. Restoran Nelayan Langkawi to Sultanah Maleha Hospital Langkawi. Sultanah Maleha Hospital Langkawi to Taman Seri Aman. Taman Seri Aman to Taman Langkawi. Taman Langkawi to Taman Berjaya. Taman Berjaya to Kampung Bakau. Sultanah Maleha Hospital Langkawi to Taman Kenari Batu Asah. The Fat Frog to Restoran Siti Fatimah. Restoran Siti Fatimah to Kampung Mawar. Vertex 1 to Perdana Service Apartment and Resort Form. Perdana Service Apartment and Resort Form to Alia Resident Business Resort. Alia Resident Business Resort to Kampung Regot Besar. Kampung Regot Besar to Kampung Regot Kecil. Kampung Regot Kecil to Rumah Bendang Langkawi. Rumah Bendang Langkawi to Kakak Western Food. Then, we must sum up all the weight of the edges. The total weight is 111.
So, let's conclude this video with the importance of the minimal spanning tree. Minimal spanning tree has direct application in the design of networks. It is used in algorithm approximating the traveling salesman problem, multi-terminal minimal cut problem, and minimal cost-weighted perfect matching. There are many more practical applications for minimal spanning tree. Some of other practical applications are cluster analysis, handwriting recognition, and image segmentation.
That's all from our group. Thank you for attention. Goodbye. Assalamualaikum warahmatullahi wabarakatuh.